The March 2008 demonstration at a Scania facility near Stockholm, Sweden, demonstrated smart data for smart machining, showing how STEP-NC can integrate process, tolerances, wireless measuring equipment, and ISO 13399 tool descriptions for more accurate machining. The demo was designed to show the benefits of STEP-NC to automotive industry and used a simplified test part representative of the types of machining operations used at Scania to finish a cylinder head. The sample part was machined on a hard-hinge mill with a Siemens control that was outfitted with a STEP-NC interface. The STEP-NC machining program contains the tool paths, process parameters, and tolerances, as well as CAD geometry for the final part, stock, fixtures, and cutting tools, so a STEP-NC interface can show the process in context at all times. After machining, the part was measured to verify that it was within tolerance. The STEP-NC interface can display the measurements in context and provide color-coded feedback on the part. Using our three-handed assistant, the thickness of the block is measured and the value is sent from the wireless gauge back to the control. When this is compared to the tolerances in the STEP-NC machine program, it is found to be too large and the affected faces are highlighted in red. A similar measurement is made for the depth of the counterbore, but here the value is within tolerance, so the counterbore faces are shown in green. The diameter of the counterbore is also measured and found to be out of tolerance. If you look closely, the side of the hole is shown in red. Measurements of the surface finish are also entered and compared against the finish called for in the STEP-NC program. Here on the STEP-NC interface, we can see the allowable tolerances as well as the as-measured value from the wireless gauges in parenthesis. Some faces may be related to more than one tolerance. The top face satisfies some tolerances but violates others. The individual tolerances are shown in red or green, but in summary the face is shown in mixed yellow. By using the linked geometry and machining information, the STEP-NC interface can identify the tools that affect the tolerance. One tool might be used for many operations, the result of which might be good, bad, or mixed tolerance values. Combining normal tool dimensions from the STEP-NC program and in-use tool dimensions from an ISO 13399 database, the STEP-NC interface analyzes the orientation of the part faces, operations performed, and tolerance stack-up, then recommends tool compensation values. Whether the operator chooses the advised values or others, the compensation values are sent to the CNC using its appropriate internal codes, such as the Siemens TC-DP registers. Typically, machinists at the facility are given work instructions that describe the relationships between faces on the part and the tolerances related to the cutting tools used. Creating and maintaining these work instructions is time-consuming, even with automated tools. But using STEP-NC, this information is available directly from the machining program. Here we see the list of tools with values for tool diameter, length, and corner radius. The nominal values came from the STEP-NC program, while the in-use current value is shown in parenthesis and was taken from an ISO 13399 tool parameter file. A red icon is shown next to some dimensions to indicate that a different value is recommended. The icon changes to green when the dimension is confirmed, using either the advised value or another of the operator's choosing. The part is then cut again with the updated values. Cutter contact tool paths are used for the finishing pads. Finally, our three-handed assistant measures the resulting part and verifies that the new compensation values result in good dimensions for all of the tolerances. This demonstration used wireless probes, but a STEP-NC program can also contain more formal inspection operations to drive an on-machine probe or separate CMM. Other participants at the March 2008 demonstration showed how to optimize feed and speed rates by adding cutter cross-section area parameters to the STEP-NC file. They tested STEP-NC with high-speed machining and demonstrated new approaches for representing large volumes of toolpath curves. And they showed a series of traceability extensions for linking STEP-NC machining programs with sensor feedback and machine state information during execution. STEP-NC is smart data for smart machining. By using the rich data in STEP-NC to associate tolerances, machining operations, the tools they use, faces on the 3D geometry of the machined part, and ISO 13399 in-use parameters for the tools, we can simplify tolerance-driven tool compensation for more accurate machining.